Hi, I'm Belekiso Adenrito. I'm a business data analyst at Business Data Lab, Abuja. I'm also the organizer of Abuja R User Group. In this video, I'll be walking you through a machine learning project used during our February meetup, where we looked at introduction to machine learning project workflow. We used K-means clustering method to segment customers based on their spending score and annual income. Dataset belongs to a shopping mall. So let's jump in. Here I'm having my R Studio opened, and I'm going to be using different packages to achieve the aim of segmenting our customers. So I'm going to be using the Tidyverse package, GG Repair, Scheme R, and the Broom package. So we're going to follow the workflow as rightly described in the comments up here, but since we're working with unsupervised machine learning techniques, we're not going to be looking at training and testing and training a model based on a labeled data. So we're using unlabeled data right now. So I want to load the packages into R Studio. So I'll run each line. So from the comment, we're going to be using the Broom package to get us the statistical analysis of our model in a tidy form, that is in table format. So here now, let's get in our data set. So we have it in a CSV format. So we're going to read it in using the read_CSV. I was saving it here as mall table. So we want to take a glimpse at what we have in our data set. So here we'll look into our console. We can say we have the customer ID, gender, age, annual income, and the spending score. We can also go to the environment, click on the name of our data, that's our table, and we'll get it to have a table format displayed to us. So we can see what we have here, the same variables and their various data. So we'll go back to our script. So here we want to take a look at the summary of our data. So we run the summary function on our data, that's our table. So here we have some statistical feedback, that is the output here. But there is a better way of viewing what we have here for those who don't have much of the statistical knowledge. So we can have a readable display of the summary by using the scheme function from the scheme R package. We'll pass in our table as the value for our argument. So we run this. So now it's simpler to understand what we have in our data, in our table. So here, the name of our table is multi_table. We have 200 rows of observations. So we have 5 columns. Out of the 5 columns that we're having, 1 is character type and the remaining 4 are numeric. We also have information about the number of missing values. We have none here, so the data is complete. We have the minimum, maximum for each of the character variable. So here there's no missing value for gender, and the minimum, maximum, empty. All these are some of the statistical information that have been passed in. So when we go to the numeric values, here we have the customer ID, age, annual income, spending score. There are no missing values as well. That's complete with. So we have the mean for the customer ID, which we're not going to be using. So, but for the age, the average age is like 38, like almost 39. So here, the annual income, the average is 60.6, while the spending score is 50.2. So the standard deviation is here, as well as the P, and for the other values for the statistical information. So we're not going to go into this detail so we don't get out of the scope of what we're looking at here. So we'll go back to our script. So now we want to visualize the distribution of the values in each of our variables that we're talking about, numeric values. So we want to look at the age. Let's take a look at a histogram based on the age values. So here we're going to be using the function ggplot, which belongs to the ggplot2. In our upcoming classes, we're going to be looking at data visualization, and here we're going to explain more about ggplot. We'll talk more about ggplot, the various types of plots. So keep in touch with us as we go along. We have an R learning lab going on right now, so you still have the opportunity of joining the class if you're interested in learning more about R. So it's online. It's online basically 75% of the periods, and it's on weekends, Saturdays. So you're welcome to join our class. So now we'll go back to plotting the histogram. So I'll run this line of code. So we'll look at the plot section here. You can see the distribution of the age value. It's still, the data is well distributed, but there is still skewed to the right. That is positively skewed. So still having the tail on the right side. So a bunch of it are going to the left. So that means we can still do some things on our data to prepare it for the model we're using, or techniques that we're going to be using. So we'll continue. We want to look at using the density plots. So you can see the spread much more meaningful here. It's getting better. We can see, okay, a bunch are mostly onto the left and it's kind of slowing down. So we have fewer customers belonging to between the ages of 60, 70. So another way we can make sense of the age values is to use the box plots. This helps us to have a better visualization. Let me zoom out. So we can see with the box plot helps us to look at the median of our data, which is falling between, that would be like 36, like 36 or 7, so up to 7, almost 37. So, and then we calculate, we got the summary from the scheme function, which we can go back to it, and we can say we have a bunch of the data is concentrated between this area. We're going to get more into interpretation of the box plot. I don't want to go too much into this because we've not treated that as of this class. And here we're having no outliers displayed for us. All this we're going to get a much more better understanding in our upcoming classes on data visualization. So we'll continue to look, we'll take a look at some of the other plots that we used during the class. This is a bar plot that's showing us distribution of the number of females and the males that are within our customer data. So we'll go on to look at the variation between for the gender and the age. The distribution is shown here. So we'll move on. So this is a plot for the histogram. You can see there are some issues here. There's a gap in between some of the values. There's a way we have to normalize this, and this will surely going to, this is just a project to take us through the machine learning workflow. So the deep understanding of this is going to come up in our classes on machine learning. So, but we have to appreciate, okay, get us to be in the mood to learn more. That's why we're looking at some specific topics at the end of each month as we go along the R Learning Lab. So we'll move on to the spending score. Then this is the plot for the box plot, showing the relationship between the age and the gender variable. So you can see the distribution of the ages here. So the median is different for the female is, for the female now we have something like 36, but for the male we're going up like 37, 38. So for the annual income and the gender, same thing goes, there's variation there. So we look at the spending score, the same thing goes. So you can see there's big difference, the gap is there. So female are much more on the higher side with their spending score. So now the next thing is to look at normalizing our data. To work with K-means clustering techniques, we need to normalize our data. Normalizing our data means we have, for each of the features of variables, the mean has to be 0 and the standard deviation should be equal to 1. So, and we shouldn't have missing values. And from what we have earlier, we don't have any missing values here. But we can still check to know which of the rows has missing value by using the function which returns the index, while the nested function is.na helps us to check if any of the value contains NAs. So if we run this, we can use this to cross-check again. We can say we're having 0 returned to us there, so we don't have any missing values. So let's look at the means of each of the variables that we're targeting here. We're looking at the spending score, which belongs to the first column, and the annual score. I think, okay, let's look at our table. So we have the annual income on the fourth column and the spending score on the fifth column. So go back to our script. So now we want to look at the mean for each of these two variables. So you can see here, we have for the annual income, we're having 60.56, and the spending score 50.20. We got that the value while using our scheme function here as well. So for the spending score, you can see 50.2 and the annual income 60.6. So now let's look at the standard deviation. So we're using the map function, which is part of the Power package, also within the tidyverse. We're using it to map this function, the standard deviation function, to each of the columns here. So we're passing in, we're subsetting the value and passing it into the map function. So it's going to be used on each of the columns. So here now we have, for the annual income, the standard deviation is 26.26472, while for the spending score we have 25.8. So obviously we have to scale the values here, although there's not much variation between the annual income looking at their standard deviation, but we can still go ahead and compare scaling our data and not scaling our data. That will be an assignment for you to do. So now I'm going to scale the data. So scaling the data using the function scale will return a matrix to us. So we need to convert the matrix into table because we're working mostly with functions that are dealing with tables. So we're going to do this now. We're saving it as scaled mul table containing the two variables that we're targeting for our segmentation. So we'll run this line of code, and we have that now. So we can click on the name and we'll see the values we're having here has been scaled and it's different from what we have before. So we have here 1539. Scaling helps us because both the annual income is in my monetary value, while the spending score is just numeric values that are representing how each customer is spending. There is a score that is assigned to each of the customers. So the metric is different for both of them. So we just have to do some scaling. Sometimes there might be no need to do the scaling. So but here we're going to use the scaled version of the data. So we'll go ahead to look at the mean, which is obviously going to come down. It's now negative. Now let's look at the standard deviation. So good. We have the standard deviation now as 1. So that means our data is normalized to be passed into the k-means function. So we'll go ahead now. Now we want to run our model. We've already known that we're using the k-means clustering method techniques to get the clusters that's the groupings for our customers based on their spending score and their annual income. So, but before we do that, k-means clustering method is iterative. We need to set the seed value before we run the function so that we'll be consistent. We have a repeatable value that is being given to us. So now I'm going to run this. Then we'll go ahead and look at the k-means function. To get more information about some of the functions that we're using here, if you're not clear about it, there is a way you can get help in RStudio. We just need to go to the console, type the question mark, put the name, type in the name of the function that you're using that you want to know more about, then just click enter. You'll get the help tab opened up and you'll get to see more information about the functions that we're using. So you can see the k-means function is telling us that okay, this is for clustering. So the description gives us that okay, the function is going to perform k-means clustering on a data matrix. The data matrix is described there, is represented by X. So let's look at what we have here. It accepts numeric matrix of data or an object that can be coerced to such a matrix. So now we're talking about data frame. And the simpler version of data frame is our table. So obviously now we can pass in our table into the function and we'll get the object, the k-means object out for us. Also, we have the argument on centers. We assign an arbitrary value of centers to the center. In the center argument, we can decide to start with a 3 or 2. But there's a way we can get the actual value that represents the number of clusters that gives a better insight into the data that we're working with. So here we just want to look at, okay, what do we get out of the k-means function when we pass in our data. So we're going to run this. There are other values in the k-means functionality, but I wouldn't want to go too much into this detail. But these are going to be treated in our machine learning class coming up. So we have the number, the end start. This represents how many random sets should be chosen. How many times should we randomly swap the clusters, the number of the clusters, that's the centers of each of the clusters, to get more of the customers that are going to belong to each of the clusters. Let's see which ones make sense. So we can assign any number of random set that you want to create out of the data that you're passing in. So now we're using 50. So we're going to run this line of code. So we can now take a look at the k-means object. If you look at this, let's run this line and we'll see what's going to be returned to us. So now here we're having k-means clustering with 3 clusters of sizes 123, 38, and 39. So the first cluster is having 123 customers. Then the second one, 38, the third, 39. So the clusters now, here, we're having for annual income for the first clusters. For the first cluster, we're having this the value here, and this is the centroid. So that's the center of the cluster. So for annual income is this, and then the second cluster, this value, and so on. So the same thing for the spending score and for each of the clusters. So we have the numbers that are assigned to each of the customers. So you can see we have clusters in ones, the ones in twos and threes, the third column, the third clusters. So we have the values for the within cluster sum of squares here, which is calculated by the between sum of squares divided by total sum of squares. Other available components of the k-means object are stated below. So we can get more information by calling up each of the variables that are within the k-means object. So we can do this, and we have the clusters, then the centers. We run that as well. So now we've just created a k-means object for a value of 3 that's been assigned to the centers. Now we need to create a plot called the script plot, which is going to help us to determine which is the perfect or the close to perfect number to assign to the center argument in the k-means function. So here we need to iterate through these values by creating a function that I'm going to give the name k-means function. So we'll go ahead and run this. So now we have in our environment, we have the k-means function here that we can use. Here we're running, we tested the function or created the function using the value 2, which we are going to change. Okay, so now we'll go ahead. So now we want to create a mapped data set, that's a table. So here we want to create a table containing ranges of values for the centers arguments in the k-means function from 1 to 20. So this, when we select this line of code and run it, it's going to create a variable named centers from 1 to 20. So we'll now map this into another line of code, which is going to help us to create a k-means object, which is named k object, by assigning each of the values of the centers, that's 1 to 20. Then we'll map the k-means function to each of these values within the column. So that will get us the k object. Next, we're going to move ahead to use the k object to get out a value that is in the table format containing only one variable. So as described here, the glance function belongs to the Room package. So it's going to provide for us a one-row summary of our model. So we'll now go back to the line of code and run the entire code. So here, I'll run it. So let's take a look at what we have. So we can see we have the centers from 1 to 20. Okay, and we have the k objects as lists for each of the values. Then we've gotten out the glance, which is just a single column containing the values that we needed for each of the centers. So here we're having the total sum of squares, the total within sum of squares, and the between sum of squares are the iteration. So here it's just one iteration that is being done. So same thing goes for the other values. So now we're going ahead to, we're moving forward to creating our script plots. So here now we want to create the plot. So we're going to be passing in the center values and the total within sum of squares. So this is going to help us to create the script plot, and we're going to get a value that corresponds to the elbow point on the script plot. This is the point that we need to take the value corresponding to the point, and that's the best value that we can create, that we can use to create our clusters on. So I will run this line of code. Okay, good. Now we have our plots. So if we look at the plot, we can see there's a sharp drop between 1, 2, 3, 4, and 5. But as from 5 to 6, there is just the drop is very, very small. So same thing goes down up to 20. We're not seeing any significant change in the drops of in the values that is being returned by the total within sum of squares. So this is the value that we're going to be using to create our clusters. At the end of the day, we're going to compare the clusters that is being returned using the value 5 and another number that we might decide to use, maybe something like 2 or 3. Then we'll now look at the plots that we'll get at the end of the day to know that, okay, now using 5 makes sense. Okay, so we continue our journey. So now for the k-means object that we're going to be using now, we're going to use, okay, here we're trying to test with 3. But since we've obtained our value as 5, we're going to put in the 5. Then we'll now come back after creating that. We'll now compare using the value 3 and using the value 5. Or maybe we should just go ahead and use 3 and see what we can come up with. So we'll run this. We'll create the k-means object. The same information is going to be sent to us. Then we'll look at the clusters that we're having. So we have clusters between 1 and 3. So we'll go ahead to augment the data. We want to combine the k-means object for the customers with the more table, where we're having all our information. And we're going to rename each of these the columns that we want to give it a different name. That's just what's happened here. So we can now look at our customer cluster. Now we have our customer ID, gender, age, annual income, spending score, as well as the cluster, the number of the cluster, the number representing the cluster in which the customer belongs to. So go ahead. Now we want to create our cluster, the plot for that shows our cluster. Okay, now let's zoom. So if we look carefully at the clusters that we're having here, we can see for the clusters in one, the customers in cluster one, there's a gap, a big gap between the customers, the points in the cluster, because there's kind of like we have one distinct area containing some customers that are further up the spending score, while some are just down here below. Then there's some that are highly concentrated within the middle. And we're now saying that, okay, this will be just one cluster. No, it wouldn't make so much sense. So that means creating 3 clusters would not make so much sense to the feedback we're going to give to maybe the marketing department. That, okay, target your campaign or structure your campaign towards these groups of customers. So now we have the other ones that are much more better, as the customers in clusters 1, okay, actually 1 and 2, 1 and 3 are okay, but the clusters in 2, not so much. So now we're going back. We want to go and change the value to 5 and see the difference. So now I'm going to run the info, these lines of codes again. Then we have customers in 2, 3, in 4, 5, 1, 3. So we augment again to combine the data from the more table and the k-means objects. So now let's do the plotting. So now let's take it better. Can you see now we have a better description of our customers? You can see here before using 3, we have all these segments, all these customers, all these points are just one cluster. But right now, when we use 5, we assign 5 to the census argument, we have much more distinct clusters of customers that we can now tell the marketing department that, okay, we need to focus more on these 5 groups of customers based on their spending score and their annual income. If we want to interpret this now, down here, there's the customers in cluster 2. They have lower spending score as well as their annual income is low. For those in cluster, that will be cluster 4, they have higher spending score while their annual income is still low. Those in the middle, that will be cluster 5. They are in between. They have the medium, the average spending score and average annual income. So those in cluster 3, they have higher annual income but lower spending score. While those ones in cluster 1, they have higher annual income as well as higher spending score. So each of these clusters would be needing different marketing campaign that will be targeted to them. So they are not going to get the same marketing email or SMS sent to them. They have to be sending based on the relationship, the similarities between between them. So there are features that are similar that we can use to relate to the customers in each of the clusters now. So moving on, we can further go ahead to help the marketing department by bringing out details of the customers as well as the clusters where they belong and the description of each of these clusters, their description based on their spending score and their annual income. So here we'll quickly run for each of the clusters. 1, 2, 3, 4, 5. So we have for all the clusters now. For cluster 1, you can see we have all of them. We have 39 observations. That corresponds to 39 customers there. For cluster 2, we have 23. Cluster 3, we have 35. Cluster 4, and so on. So we have 81 in cluster 5. So this can help them to now target, okay, this group of customers were sending this email and so on. So this comes to the end of the project that we used during our last time. That's our February meetup. So I hope you enjoyed it and will make more sense of it by going through the codes each line of codes one by one. So thank you so much for staying with me and hope to meet some other time. And please check our YouTube channel. That's Abuja our user group on YouTube channel to follow up on our upcoming videos. Thank you so much.